Good day, viewers. Today we want to take ourselves through practical steps on how to read WAEC questions and answer them correctly. If a candidate is going to excel in a particular exam, such candidate should be able to read the question correctly and interpret it correctly. And that's what we are going to be dealing with as this lesson is concerned. We are dealing with the 50 objective questions for WAEC of year 2014 WAEC questions. So let's get started. The first question says, a ball falling through a viscous liquid is acted upon by, in another way around, they want to let us know the forces that is acting on a body or an object that is falling through a viscous liquid. So let us assume that we have a container like this and we have our object like this. We call it ball as this question is concerned. So this is our viscous liquid. Number one thing that we need to know is that as this viscous liquid is concerned, or the object particularly, the weight of the object is acting downward, that is mg. The weight of the object is acting downward, mg. And another force that is acting on the object according to Archimedes' principle is what is called the upthrust. According to Archimedes' principle, there is an upward force that is acting on every object that is submerged or totally immersed in a liquid. That is the second force. Don't forget, the first force is the weight of the object, the weight of the ball, and is acting downward. According to Archimedes' principle, as I've explained earlier, the object is now as the object is moving down or is being suspended in a liquid, there is an upward force that is acting on such object. The kind of force that is acting on such object is what is called the upthrust. And the liquid itself is giving the object a viscous force. That's the frictional force that is present between the molecules of a liquid, and it opposes the motion of the object that is falling through the object. For example, let's say the object is moving downward, as the question has just stated that a ball falling through a viscous liquid is falling through, so it means that it's falling down. Definitely the viscous force will be an opposing force. That's frictional force anyway. Opposing force that will be acting on the object. So the three forces that are acting on this object now is the first and foremost the weight that is acting downward, the upthrust that is acting upward, and the viscous force that is acting in opposite to the direction of the motion of the falling object. So mathematically we can simply say weight minus upthrust minus viscous force equals to mma if the object is actually accelerating. But if the object is not accelerating, we are going to have W minus U minus viscous force equals to 0. When the acceleration is 0, that's when the object is not accelerating. So as this object is concerned, this question is concerned, we can see that the three forces that are acting on this object, they are number one, upthrust, the ball weight, and the viscous force. So the correct option now is option D. Option A says upthrust only, which is actually wrong. It is not upthrust alone that is acting on the object. Option B says upthrust and the burst weight. So we should not forget, yes, these two forces are acting actually, but they are not the only one. So this is wrong. The burst weight and the viscous force. So can you see now? So we have burst weight and the viscous force, but they are not the only one. So the correct option is option D. So let's quickly go to, if you have any question to ask, you can drop your comments on the comment section. And this video, in order for you to get more of our uploads, you can kindly subscribe to this YouTube channel, like the video, make sure you share it among your friends so that they can also be of benefit of this lesson. So let's quickly go to question 2. Question 2 says an object of mass m moves with a uniform speed v round a circular path radius r. If its angular speed is w, the magnitude of the centripetal force acting on it is, so what is a centripetal force? Is an inward force that is making an object, that is keeping the object to move around in a circular path. And then this centripetal force mathematically can be expressed as ma, the mass of the object, and the acceleration of the object. So mathematically, centripetal force is ma. So what is our m? M is mass of the object that is revolving around in a circular path. So what is our a? Our a mathematically is the linear velocity multiplied by the angular velocity. But when we check our option, we see the options are given to us in terms of WR or VR or okay. Even the 4 options are given to us in terms of either WR or VR. That shows that we need to do some arithmetic like that on that. We need to recall that W is the same thing as V over R. That shows that, therefore, when we now say A equals to, instead of this W, we can simply substitute R. V over R for our words, for our W. So at the end of the day, we are going to have A equals to V squared divided by R. So we can now see that in terms of uniform speed given to us in the option and the radius of the circular path given to us, we can get our acceleration. Therefore, we can simply say centripetal force, which is ma, is the same thing as m. We now substitute this a. We are going to substitute this a for our acceleration in form of v squared divided by r. So when we check the option A says m equals to w squared r, which is not correct, which is wrong, is not correct. B is equals to v squared, mv squared divided by r, and that's the correct option for it. But let's still check option C. Option C says mw squared r. mw squared r. I think this should be divided by R, because option A and option C are the same. So option D is telling us that M equals to V square divided by R square, which is not correct at all. It's not correct. It's not part of this. This is wrong. This is wrong. So our correct option now is option B. Option B. So let's quickly go to the next question. The next question says, when an elastic material is stretched by a force, the energy stored in it is A. Kinetic, B. Potential, C. Thermal, D. Electrical. So before we could be able to pick the correct option for this question, so let us just assume that yes, we have a catapult here. Our catapult is being made up of an elastic material of this nature. When it is being stretched backward, so there will be an extension. There will be an extension as a result of the application of force. So the kind of energy that is being stored at that moment is what is called, you see that nothing has been moved. When after being stretched, nothing has been moved. So we can see that kinetic energy, which is our option A, is kind of energy that is deal with motion. Option B, potential energy, the elastic material is at rest. So we can simply say at that moment the kind of energy that is present is what is called elastic potential energy. So option C says thermal. We are talking about heat. When we are talking about thermal, we are talking about heat energy. And then when we are talking about electrical energy, is as a result of movement of electron, and we are not talking about that here. So option A is wrong. It's not kinetic. Option B is potential, which is correct. Option C is not correct as well, and as well as option D. So the correct option is our option B, potential energy. So let's move on to the next question. If no net force acts on an object, the object maintains a state or constant speed in a straight line. The above is a statement of Newton's. So they are trying to ask us that out of the Newton's law of motions that we have, which one is being described here? And we need to recall the three Newton's laws of motion. The first one says that when an object is at rest or is moving in a uniform speed, we continue like that unless an external force acts on it. So even from that, we are going to see that the correct option for this is what? Is our option A. That statement is actually describing Newton's first law of motion. But let's proceed and see what is Newton's second law of motion. It's just talking about that. It's just talking about the time rate of change momentum, or the change of momentum of an object is directly proportional to the applied force or impressed force. Mathematically, we can say that mv minus mu directly proportional to the force applied. So we can now say that over t, the time rate of change momentum is directly proportional to the impressed force that causes the change. So mathematically, we can say F equals to K mv minus u over t, and this is why we have m equals to ma when our K is 1. I'm very sure by now you can remember the Newton's second law of motion. The third law is talking about actions and reactions are equal but opposite. You see that from that statement, it's not talking about what we have been given in the question at all. And law of gravitational is not related to that at all. So let's quickly go to the next question. We can see from here, option B is wrong, option C is wrong, and option D is also wrong. We can say option A is the correct one. So let's quickly go to the next question. The next question is telling us that which of the following velocity time graphs below correctly describe the motion of a body pulled by a force that is equal to the frictional force acting on it. What's the meaning of this? Let us assume that we have an object and the force that is being applied along this direction, this is applied force, and the frictional force which is opposing the motion is directly opposite to the direction of the applied force. Let's say this is our frictional force R. Frictional force R. According to the question, let's see what happens when the applied force is equals to the frictional force. And when applied force is equals to the frictional force, we are going to see that the object will not move. The object is in a place of rest. Before this object can move, it means that the applied force must be greater than the frictional force. So when applied force is equivalent to frictional force, the object will still be in a state of rest. It will not move. And when it is not moving, it means that there is no acceleration. So the velocity time graph for what has happened is there is no acceleration. So when we plot the graph of velocity at that moment, and when the object is stationary, when we plot the velocity at that moment with what? With time, the velocity is zero. The velocity is zero, or let me say it moves with a constant velocity. It can move with a constant velocity to show that the velocity will just be constant when we plot it against the time taken. So how do we get this? Is because our acceleration is zero. There is no movement. The acceleration is zero. The acceleration is zero. So the first answer from the diagram, from the option A is trying to tell us that yes, the velocity increases with time and increases sharply from here probably to here, but after that there is a curve. No, there is no acceleration at all. So option A is not option A is wrong. Option B, you see that V and T, when you plot the graph of velocity against time, there is a linear graph to show that there is acceleration. But we have come to the conclusion that in this question there is no acceleration. So definitely when we find the acceleration here, option B is wrong, option B is wrong, option C, that's when there is no acceleration. So option C is actually correct. Option C is the correct answer. And you see that option D is somehow the same thing as what? As option A. So the correct option here is nothing but option C. That's when acceleration is zero. When acceleration is zero, when we plot the graph of velocity against time, it will show a constant velocity. So when we have a constant velocity, it shows that the acceleration is a zero. So let's quickly go to the next question. When the linear momentum of a body is constant, can you see now from Newton's second law of motion, when the linear momentum, what is the linear momentum of a body? Is linear momentum is mass multiplied by velocity. Mathematically, we have linear momentum to be m multiplied by v, and when we have final velocity from initial velocity, we can simply say m final velocity minus mass initial. This is mv. We use v for final velocity and we use u for initial velocity. So this is now final momentum. mu is initial momentum. All right, now the question is now telling us that when the linear momentum of a body is constant, that shows that the final velocity and the initial velocity are the same. That shows that our change in momentum will not be what? Will not be zero. So we need to recall that F is equals to m into brackets v minus u all over t, and this is our change in momentum, and we have been told that this change in momentum is constant, which is the same thing. When the linear momentum is the same thing, that shows that v minus u equals to 0, or mv minus mu equals to 0. Definitely F will not be 0 over t to give us 0. So that shows that the net force acting on it will now be 0, which is option A, the first option, which is the correct option. Option B says increase. No, it's wrong. It will not increase, decrease, and it will not remain constant. So when linear momentum of a body is constant, the net force acting on it is what? Will now be 0 according to Newton's second law of motion. So if you have any question, feel free to put it in the comment section. Anywhere you don't understand, we are ready to serve you. Just make sure that you like this video, you subscribe, you share it among your friends. It will be of benefit to them as well. So let's quickly go to question 7. Question 7 says, which of the following pairs of physical quantity is made up of vectors? So what's the meaning of vector? We need to understand the meaning of vector before we can pick our option correctly. What is a vector? A vector quantity is a quantity that has both magnitude and direction. It has both magnitude and direction. So, and we have various examples of them, but let's quickly go to our given options. Option A says speed and displacement. Now, speed is a scalar quantity, although displacement is a vector. But don't forget, the pairs must be what? The two of them must be vector. Now, mass, option B. Option B is telling us that mass is a scalar quantity as well, while force is a vector. Yes, mass only have magnitude, while force has both magnitude and direction. The third option, option C, displacement is a vector and acceleration is also a vector. So that shows that this is what? This is our correct answer. But let's still go to option D and see what is there. Option D says momentum and length. Yes, when we are talking about momentum, like I said earlier, is mass multiplied by velocity. So, and since the velocity is a vector quantity, the momentum also will be in the direction of that velocity. So momentum also is a vector quantity, but length is just a scalar quantity. So our correct answer is option C. Let's go to question 8. The next question. The knowledge of surface tension is applied in the following areas except in. So what is surface tension? Surface tension is just a phenomenon that make the surface of water to act like an elastic skin. For example, the reason why a needle that is being made from metal or metalloid can still float on the water, despite the fact that the needle is denser than that water. So what make a needle made from a metal that's supposed to sink in the water in a normal sense to be floating on such water is what is called the surface tension. And where do we apply surface tension? The option says manufacturing of raincoats. Yes, surface tension is being applied in the process of production of raincoats, umbrellas, and that's the reason why these objects, both raincoats and umbrellas, they have oil-based material in their production. That's the reason why when rain is now falling on them, they will be repelling such rain. So surface tension is applied here. Production of palm oil. You will see that when we are talking about production of palm oil, there is nothing called the application of surface tension here. And option C, floating of a needle on water. That's what I will explain. Yes, we also apply surface tension here. A needle will float on the water despite the fact that the needle is denser than water, which is supposed to sink. But when water now behaves as what? As elastic skin, that's what is called surface tension. And the option C is washing of plates with soapy water. Yes, when we have plates, that oily plates cannot be washed away by only water, alone. So when we have a soapy water, we can see that washing of plates with soapy water, surface tension is being applied. So that's where we can wash the plate thoroughly, and this is the application of surface tension. All right, actually the soapy water now reduces the surface tension of the water in order for it to be able to wash the plate correctly. So let's quickly go to the next question. The next question says a body is projected vertically upwards with a speed of 10 meters per second from a point 2 meters above the ground. Calculate the total time taken for the body to reach the ground. So let's quickly draw what happened here. If we interpret the question correctly, the Question says from a particular height 2 meter. That's when from the ground, this is the ground level now. This is our ground level. From this ground level now, or let me say from this height, the object is being projected vertically upward. With what? With velocity what? With velocity u equals to 10 meter per second. Alright? We are asked to calculate the total time taken for the object to reach the ground. So we need to do a little analysis from here. The first thing we need to check is what is the time taken for the object to reach the maximum height. So when we know this time taken from here to here, let's say is time t, and then from here to here downward, we now calculate another time. Let's call this t1. The second time is from here to here, which is t2. So our total time taken will now be capital letter T equals to t1 plus t2. I'm very sure you get my explanation like that. The time taken, the journey of this object, we have a time taken from this point A. Let me try and locate this point A from where the object is being projected to the maximum height, point B, and from this point B to the ground level, which is point C. So that's how we are going to do it. Now, what is the time taken from level A to level B? We are going to make use of our equations of motion, and you are going to agree with me that the one that is crucial to this is V equals to U minus GT. Wait, why am I using a negative G? Because the object is moving upward. The object is moving upward. Whenever an object is moving against force of gravity, the object is actually decelerating, retarding. So we cannot say at maximum height, yes, at maximum height, our final velocity for that journey will be 0, simply because the object will come to a rest at level B, which is our maximum height. The object will come to a state of rest before starting coming down. So at B, our V, the final velocity will now be 0. Don't forget, from this level, our initial velocity is 10 meter per second, and we have been giving G to be what? 10 meter per second square. So let's quickly calculate our T. We can now say V equals to U minus GT. V is equals to 10 meter minus 10 T1. Don't forget, I've used T1 to denote the time taken from level A to level B. Alright, so from there I can now say that this T1, okay, don't forget this V I said is 0. We now have 10 minus 10 T1. Therefore T1 equals to 10 divided by 10. How do I get this? Now, by the time you make T1 the subject of formula, you are going to have 0 plus 10 T1 equals to 10. I mean, when you transfer this one to the other side. So from there, we can now have 10 T1 equals to, this is 10. Don't forget, this is 10. So 10 T1 is equivalent to 10. So that's how we obtain T1 equals to 1 second. That shows that the time to reach the maximum height from this level A to level B is nothing but 1 second. Now, what is the time taken from this level B to the ground level, which is our level C? To get that, we need to know the distance, the height from level A to level B. When we know the distance from level A to level B, it will give us the understanding of the particular height that the body moves from level B to level C, which is our ground level. So let's quickly check the height, that is the distance from level A and level B. Level A from this point A to point B. Let's see the height, the distance covered by the object. So how do we get the distance covered by the object? Number one, we need to take note that we are giving initial velocity to be 10 meters per second. Now, at maximum height, V will be what? Will be 0. Now, we know our T to be what? To be 1 second now. So, among the equations of motion that we have, which one suits the best? You are going to agree with me that we can make use of S equals to ut minus half gt square. This is one of the equations of motions that we have, and this is distance is changed to height because we are dealing with vertical distance. The initial velocity is 10 multiplied by the time taken now, which is 1 second, minus half into brackets multiplied by 10 multiplied by 1 square. Definitely, we are going to see that h is equals to 10 minus half of 10, which is 5, times 1. At the end of the day, we are going to see that this is 10 minus 5. Therefore, our h is now 5 meters. Now, maybe someone will ask me, we are not making use of our final velocity again, which is 0 at the maximum height. Yes, we are not using it in this calculation. We can also use it in another equation to get the same answer. How? We need to recall that one of the equation of motions that says v square equals to u square minus 2gs. Why am I using minus? By now you should know the reason why you have negative in that equation, because the object is now moving against the force of gravity. Likewise, the reason why we have negative here as well. So at maximum height, we have v square equals to 10 square minus 2 times 10 multiplied by h, because we are dealing with height. So we have 0 equals to 100 minus 20 h. Therefore, h, we can say 0 plus 20h equals to 100. 20h equals to 100. H will now be 100. When you divide both sides by 20, you are going to have h to be what? H to be 100 divided by 20 to give you 5 meters. Can you see now? I've used the two methods and I've obtained the same answers. I've used two equations and I've obtained the two answers. So let's quickly go back to our question. Our question now says, how do we get T2, the second time, the time taken from level back to level C? And then how do we now do that? How do we do that? It's very simple. It's very simple. Don't forget our height now will now be from level B. From here to here now is 5 meter. So from B to C now, the height of BC, the height from level B to C will now be 5 meter that we have just calculated plus 2 meter. So the total distance, the total height we are dealing with now is 7 meter. Now the height we are dealing with now, the kind of height we are dealing with is our height BC, which is AB plus BBC. Don't forget, AC rather, AC. Don't forget, AC given to us is the 2 meter, and AB given to us now is the one that we have calculated, which is what? 5 meter. We now have 7 meter. All right. Now from here, we can now see that we are dealing with height of 7 meter. So we have h of 7 meter. All right. Now when the object is now coming down, the initial velocity will now be 0. Don't forget, the final velocity for the first phase of the journey will now be the same initial velocity for the second phase of the journey. So the initial velocity when the object is now coming down is 0, and then our time is t2 that I want to calculate. So how do we do this? Don't forget, we are giving g to be 10 meter per second square. Now among the equations of motions that we have, which one suits this one? When we consider the given parameters given to us, you are going to agree with me that the best equation of motion that suits this is nothing but what? But S equals to ut plus half gt squared. Why am I using positive now? I'm using positive sign now simply because the object is moving down and is accelerating. So from there we can now say h equals to, what's my u? My u is 0 multiplied by t2 plus half multiplied by 10 multiplied by t2 raised to power 2. So what is my h? I have 7 equals to 0 multiplied by t2. We have 0 plus 5 t2 squared. All right. Now from there you can simply say that 7 equals to 5 t2 squared. T2 squared will now be what? 7 divided by what? Divided by 5. While my t2 will now be the square root of 7 divided by 5. Now let's press our calculator. With the help of our calculator, we can simply know the square root of 7 over 5. 7 over 5 is 1.4. So from there we are looking for the square root of 1.4. So let's quickly check the square root of 1.4. The square root of 1.4 is nothing but 1.183. That's our T2. Don't forget, our T1 is what? Is 1. At the end of the day, we can simply say that our capital letter T, which is T1 plus T2, is equals to 1 seconds plus what? 1.183 seconds, which will now give us 2.183 seconds. That's the total time taken by the object. So let's go back to our options. In our questions, we now have what? Option A is 1.00 seconds. Option B, 2.00 seconds. Option C, 2.18 seconds. Option D, 3.00 seconds. So we are going to realize that our correct option now is option C. So let's go to the next question. Question 10. Question 10. Question 10 says that a car starts from rest and covers a distance of 40 meters in 10 seconds. Calculate the magnitude of its acceleration. So in any calculation like this, let's bring out our given parameter. So when you hear that an object starts from rest, it shows that the initial velocity u, we are using u to denote initial velocity, which is what? 0. So don't wait for anybody to tell you that. And cover a distance, we now have a distance s to be 40 meter, and we are giving time taken. The time taken to cover such distance, which is t, is 10 seconds. We now have to calculate the acceleration. So we are now acceleration A is unknown. Now look at the 4 parameters. Among the equations of motions, which one do you think we can make use of? You see that the best way that we can make use of is s equals to ut plus half at squared. Simply because we are asked to calculate this, we are given t, we are given u, we are given s. So let's quickly go and check and calculate it. So we have 40 meter equals to 0 multiplied by 10 seconds plus half into bracket a multiplied by 10 seconds square. From there, we are going to have 40 equals to, this is what? 0 multiplied by 10 will give us 0, and then we are going to have plus half a multiplied by 100. So 2 here 1, 2 here 50. Therefore, we now have what? We now have 40 equals to 50A. Our A will now be 40 divided by 50. This 0 will cancel this 0. So 5 in 4, it cannot go, we have 0. When we now put 0 here, we now have 5 in 40. It will now give us 8. So 0.8 meter per second squared, that's the unit of acceleration, is our correct answer. From there, we are going to see that option B is the correct option.